This is lesson 2 in our chemical calculations lab. In this lesson, we want to talk about balanced chemical reactions and calculating the amount of reagents that are consumed or the products that are generated from a balanced reaction. So the key steps here are, number 1, balance the reaction. Number 2, determine the mass per mass ratio of the two constituents that you're interested in. That's the key to solving these problems. And step 3 is just to scale things up. So let's do an example. If you react potassium hydroxide, here's the potassium hydroxide, which is a base, with phosphoric acid, which is here, and you get the salt, potassium phosphate, and some water. Here's the potassium phosphate. How much phosphoric acid do you need to react with 250 kilograms of potassium hydroxide? And how much potassium phosphate do you make? So step 1, balance this reaction. Determine what A, B, C, and D are. And you've done this in Chem 1, you've done this in high school. I'm not going to belabor it. Just to remind you, though, that the number of K's and O's and H's and P's on one side have to equal the number on the other side when you're done. So I've worked this out in advance and determined that should be 3, that should be 1, that should be 1, and that should be 3. And on the left-hand side, that gives us 3 Ks and 3 plus 4, 7 oxygens, and 3 plus 3, 6 hydrogens, and 1 phosphorus. And on this side, we have 3 Ks, 4 plus 3 is 7 oxygens, 6 hydrogens, and again, 1 phosphorus. So this reaction is balanced, and we can go from here. So here's what we're after. We want to know how much phosphoric acid is needed per gram of potassium hydroxide. So this is the key mass-to-mass ratio that we're looking for. And what we're going to do is to first look at the molar ratios. We have 1 phosphoric acid for every 3 hydroxides, and then multiply through by the molecular weights, which are the grams per mole. So 98 grams of acid per mole, 56 grams of hydroxide per mole. Now when do you multiply and when do you divide? Watch your units. What I'm trying to do here is I'm trying to cancel moles of acid with moles of acid and moles of base with moles of base. So I end up with grams per gram. And if you run these numbers, you get about 0.583 grams of acid per gram of hydroxide. And now the third step is a cinch. I have 250 grams of hydroxide multiplied by the grams per gram so that these grams cancel, and I get 145.8 grams of acid. Now, the next step, or the part 3, is the same methodology. It's just a different pair of reagents. So here I'm interested in how much potassium phosphate is produced for every gram of hydroxide. So again, ratio of moles, 3 grams, 1 gram of potassium phosphate for every 3 grams of base. Multiply and divide through by the moles so that the units cancel. So those are the units of, that should be a K. And moles and moles until I get grams per gram again. Grams of potassium phosphate, grams of product per gram of reactant, and then just multiply through by the grams of reactant. And I get 315. So if I were to react 250 grams of potassium hydroxide with 145 grams of phosphoric acid, I should get 315 grams of the salt, potassium phosphate, and some water. Now, you try this. Pause the video and work this problem. And if you're stuck or you're ready to check your answer, come on back and look. So I'm going to stop for a second and give you a chance to pause. All right, are you ready to check your answer? First of all, you have to balance the reaction. Did you get this for your balanced reaction? All right, so I have 4 chlorides on the left, so I better have 2 of these magnesium chlorides on the right, and that tells me I need 2 magnesiums on the left. Then part 1, I want to know how much magnesium per gram of titanium chloride. That should be a little kilogram right there. And then scale it up. And so my grams of magnesium per gram of titanium chloride, which is also the same as kilograms per kilogram, I'm going to do the same way as I did before. 2 moles to 1 mole. And then the molecular weights. And so the moles of magnesium cancel. The moles of titanium chloride cancel. I get about 1/4 of a gram of magnesium per gram of titanium chloride, and then I can scale that up by multiplying by the number of kilograms of titanium chloride. All right, so there should be problems like this in your post-lab quiz. Good luck with those. And that's the end of this lesson.